See, after realizing that the decrease in the enthalpy is not the whole sole criteria on which the spontaneity of a process or a reaction depends, we came to know about another term which is called entropy. See, we are trying to find out that yes, we have processes in which the enthalpy of the reaction of that process is zero, like the diffusion of two gases. If you place those two gases in the different chambers and you suddenly opens the partition which is there between the two, but you will find that both the gases get mixed with each other. Their diffusion takes place. In this process, the overall delta H remains zero. But still this process is spontaneous, the mixing of the two. This gave us an idea that yes, it is the randomness or disorderness. Tendency to acquire, it is this tendency to acquire maximum randomness or disorderness, which is called entropy, as one of the criteria of the spontaneity of a reaction, or on which the spontaneity depends. And when we compared it with the other earlier examples like combustion of fossil fuels or combustion of the fuels like methane one, what we can make out easily is this, or the combustion of petrol or a coal, where the liquids or solids are changing into more number of gaseous substances, so the randomness or disorderness of the systems is increasing. So it was concluded that yes, it could be one of the criteria, or it could be the only criteria on which the spontaneity depends. But then we came to know about these examples, like magnesium solid when combusted in the oxygen gas, what we get is magnesium oxide solid. In this case, the enthalpy of the reaction is negative, but yet then also, and we know that entropy is decreasing because the gas is becoming a solid, randomness of the system is decreasing, but still this process is spontaneous. So again, the entropy could not be the only criteria on which the spontaneity of a reaction or a process depends. Then who decides this? It was concluded that it is both enthalpy and entropy decides the spontaneity or feasibility of a reaction. So it is the entropy, maximum entropy, and minimum enthalpy together decides spontaneity of a reaction. So they together decides this. Both of these alone cannot decide. Now let us understand the term entropy. See, it's the measurement of randomness or disorderness of a system. Whenever a heat is given to a system, obviously what happens is the motion of the constituting particles gets increased. And as a result, the randomness or disorderness increases. And it is the system's own tendency to acquire this higher degree of randomness that makes that particular system move towards that makes it spontaneous. It's a state function, and the change in its value, delta S, is called standard entropy change. Numerically, this standard entropy change is equal to Q reversible by T, or we usually put it a delta T. But since this T is taken in Kelvin, it is actually T. So it is actually whatever the amount of energy we are giving to a reversible process, because it's a state function, its value can only be determined during a reversible process. Whatever the temperature increase is being brought because of this energy which is given Q, when this is divided by the temperature change of this temperature, what we get is the entropy change of that particular substance. Now, this is a very important and valuable term because this is one of the criteria which decides the spontaneity or a feasibility of a reaction. Also remember that overall total entropy change is this delta S total is always equal to delta S system plus delta S surroundings, and this is always greater than or equal to 0. So if the system is losing entropy, its entropy is decreasing. it's the surroundings whose entropy becomes what is increasing. Overall, this is always is increasing, which is mainly the main definition of the second law of thermodynamics, which states that the entropy of the universe is always increasing, because we know that all natural occurring processes are thermodynamically irreversible, and in all those spontaneous processes which are taking place in nature, the entropy is increasing. So that is what is the basic is, and from here we reaches to the another thermodynamic important quantity, which is called Gibbs free energy, or simply the free energy.